Hello everyone. So in this lecture we'll be continuing our journey on Matplotlib, and we'll today learn about some more plots. We have been seeing types of plots, and in that we started about the data in which we have pairwise data. If we have a pair of data and we want to relate them, in that we saw different types of plots. We saw bar graph, we saw scatter plots, line plots and stuff like that. And now the first plot that today we're going to discuss is called a stack plot. Okay, so what is the stack plot? So this is also called as stacked area plot. You might somewhere see it also, stacked area plot. The different names given to this plot. So it allows us to visualize multiple data series stacked on top of each other. So there will be data, one type of series will be there, the next series will be there, and they'll be stacked on top of each other. So this type of plot is usually useful for illustrating what's called as cumulative totals. Okay, cumulative totals. This cumulative term, we'll use it many times in statistics, maybe in computer science in general. So what is this? Usually you might have heard cumulative sum and something like that. So let's suppose if we have this 1, 2, 3, 4, 5 and 6. So if somebody asks you to find the cumulative sum of this array, so what's the meaning of cumulative sum? Basically, that is, you just keep on adding the elements. You will say cumulative sum till here is 1, cumulative sum till this point is 1 plus 2 is 3, cumulative sum till here is 6, cumulative sum till here is 10. Okay, so you keep on adding the previous elements that you have seen. That is called cumulative, because whatever happened previously, you keep on doing it. This is called as cumulative sum. That's why I'm saying cumulative totals. It can be cumulative product also. It can be cumulative other aggregation operation. So these stack plots are better used when you have some data in which there is some cumulative total that you are computing. Okay, and over the different categories. It may be different categories also. Let me give you an example. Let's suppose you are running some store. Okay, something like that, or maybe you have some products. So in that you have product A, and then you have product B, and then you have, let's suppose, some services. You also provide some services. You sell, let's suppose you own a mobile shop where you sell the mobile shop, where you sell the mobile phones, and you also provide services to repair the mobile phones. So you want to see the revenue. You want to see how much revenue was generated by product A over the time, over some time. So it will be like this. So some revenue will be generated by product A, these will be timestamps, and then some by product B, and then some revenue will be given by services. So you want to sum them also. So parallelly, for product A, B and C, services, you want to sum how much revenue was generated. Let's say for product A in the first month, it gave some, let's suppose $10, that's 10 rupees, and product B gave some, let's say 15 rupees, and then services gave some 5 rupees. Okay, something like this. So 10 plus 15, 10 plus 15 plus 5. So in total, you earn somehow 30 rupees. So this 30 rupees should be visible. If you have this, the graphs will look like, they look like this. So they'll be stacked on each other. So this will be first graph for the product A. This will be second. This will be third. Okay, and they'll be colored also. They'll be stacked on top of each other. So that each point, the top point over here, so this will represent some $30 or something. Okay, so here clearly you can see that with time you can see how much is being sold of product A, and how much product B was sold, and how much revenue was generated by services also. So in this sort of scenario, you would love to see a visualization which summarizes these details. And second thing can be also like population growth by age. So if you have different age groups, and then you will see, let's suppose we have 5 age groups or something. You have people from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and then let's suppose 50 to 60 and 60 plus. These are different age groups, and you would love to see that how this population is growing in different groups. But as you can see, this also makes sense that here we can do cumulative sum, because the total population will be sum of all the population groups. Okay, and you can you'll want to try to plot the same graph here also, where we have this area plot or stacked area plot. And these are some of the examples where you can do. Similarly, we can do this for web trafficking. If you have, let's suppose, organic search, social search and things like that, you want to see how much traffic is coming from different categories. Okay, and for these things, these graphs are quite good, and visually they make more sense to use it like that. Okay, let's see how to use that. Let me switch the code window and let's code. I hope that the code window is visible. So the first thing that we'll do is we'll, as usual, import Matplotlib and NumPy, because we'll create some data. Okay, so this is import matplotlib as plt dot pipe plot as plt, and then import numpy as np. Then what I'll do is I'll maybe create 3-4 graphs. The first is I'll do this monthly revenue stream, so I'll create some sample data. So these are my imports, and then I'll do some, the first thing, these are the months, so I'm doing it for 12 months. Okay, then I'm saying product A revenue, product B revenue. This is the revenue for the first month, second month, third month, and similar like that. And this is the product B's revenue, and this is the services revenue. The example that I told you, if you are running, like, let's suppose a store or something. And second example we'll do is of let's suppose population growth, and we'll see how the population grows. This is the second data that we are creating. Oops. Okay, so if you see this, again the same thing, years, I have created years from 2000 to 20 years I have created in total. And then I'm saying age group is 0 to 14, 50 to 15 to 64, and 65 plus, some only 3 categories. And I am showing here the population growth, okay, per year, the population growth. And then similarly I can show, let's suppose, some other example of resource consumptions, okay, or maybe website traffic. Let's suppose I have here the data of resource consumption, so I'll also create that. This is just the some mock-up data, so this is not real data. You actually will have this data in CSV sheets or somewhere else. So what you will do is you will just read this data from the files by using pandas, which we have seen thoroughly. So the third example that we have is, we'll have again years resources from 2010 to 20, and then we'll say renewable energy. This is how that grows, and then we have this non-renewable energy, and then nuclear energy. So we have 3 types of energy, and we are showing the consumption each year. Okay, and now let's plot it. So how to plot it? So we want to plot at least 3 figures, because we have 3 types of data. The first thing that we should do is we should say plt dot subplots and give the number of plots that we want to create. Oops. So we'll say figure axis, figure comma axis. So here we start plotting now. So we are saying figure comma axis plt dot subplots 3 comma 1. So that is give me a row of 3 of these axes rather. So then the figure size is this. I think we should decrease it a bit. It is a bit more. So let's create it some 8 by 6. Okay, so far we'll see if this is running. It is better to test the code while you are writing, so that you don't just test at the end. Otherwise you might have to debug a lot of errors. Okay, now you can see this. I just forgot to run this cell. Okay, now you can see this. We got 3 plots. Okay. So now what is the thing is, we now want to fill each of these details. The first thing is we'll have to use a stack plot. So how to use a stack plot? The function there is dot stack plot directly. Okay, so let us do it for the first monthly revenue streams. Okay, this is the first plot. So ax0, selecting this x is 0, and then calling this function stack plot, then calling this month, product A revenue, product B revenue, service revenue, howsoever many things that you are. Now we'll have corresponding labels also. Now you can see labels and list, product A, product B, and services. And now colors, you can see the colors and it's hexadecimal. You can also write red, green, howsoever, but here we have written hexadecimal colors, so you can see that this is also allowed. And now if you want to print it, you can just maybe run the cell again. You can see this stack plot. Okay, starting from here. And if you now just want to set title and set label and legend and grid also. So by now you should be at least having good expertise over these things if you have seen all the videos. So x is 0, set the title, monthly revenue streams at the head, and set x labels as months, and set y labels as revenue in dollars, and x0 legend is keep the legends at upper left. Okay, because you can see upper left is here we have place. We can also keep it upper right here if you can write upper right. And this legend, this location also takes the value as numbers, coordinates. You can also keep it everywhere, anywhere you want. And then this grid through is basically just draw these lines. If you can now see it, this is product A, product B, and services. So this, if you just read this graph somehow, so if you just read this sort of graph, so this is the product A sales. Okay, sales are always growing. You can see that sales are always growing. They are not dipping. That's how the data was created. And then if you see at this point, you can see the total cumulative sum is around some $350 or something like that. Okay, but you can see that each thing has a share of its own. The more you go, and you can see this actually product A is selling better. So if you have to take a decision, you will take decision that I'll buy more product A. Okay, then product B, and then services. Probably you'll decrease services. You will buy more of product A because that's selling more, and product B is also selling in good amount, so that you can accordingly take decisions. But the most important thing that you have to see is the cumulative sum. Okay, by the cumulative sum I mean that at any point you can just check all the things that happened in all the revenue that you have. After 12 months you can check this is the total revenue, maybe around $1,000 or something like that. Okay, this is for product A, product B, and product C. That's why these are called area graph, because you can see the area over here. These are colored in areas. Okay, I hope that this is visible. Now we can plot the second, because the second data that we have is how is the population growing in different age groups. So again, the same thing, we can do the same thing. Okay, let me just copy this and we'll just change the things. Oops. Okay, let me just paste it. Now we'll have to change this 1, because now we are selecting the first axis. Okay, and everywhere 1. Okay, change this graph, and then this is not the monthly stream now, this is population growth by age groups. Let's suppose we'll write population growth. Let's just write a population growth, and then we have these years. Now this is not months, we have years. I am having the data on the other screen, I'm looking from there, and then we'll say let's suppose population in the millions. This is population in millions that we'll have, population in millions, and then where to keep the legend, we'll keep it there, and then instead of this months we'll say years, that is in the data. Okay, we'll say years, it's here, and then instead of product A we have these categories. We have age group from 0 to 14, from 15 to 64, and 64 plus. So we'll say age group 0 to 14, and then here this should be age group 15 to 64, and now this over here is age group 65 plus. Okay, then labels should be age group, and I'll just delete it. I'll say age 0 to, let's say, 14, and similarly we can say here age is 15 to 64, and age over here is 65 plus. Okay, and then colors, we can keep the same colors, doesn't matter. So now if I run it, and this title should be, have I pasted it multiple times? Oh, I changed this actually. Changed. So this over here should be, this should be population growth, and this is years. I just made the change in the first, I should have not done it. Then population in millions, okay, and then upper left. So I'll just cut this so that I don't want to see it. So if you now see, now I have selected the second plot. Basically the things will happen in this plot. So this axis of 1, select second axis, and then set the title and label for this, and this axis 1, years. I think this should work perfectly. You can see this now. Okay, so this is 2002.5, and we can just correct it also. And now you can see them overlapping also. So in order to add some padding, you know how to do it. That should be, you should say plt.tight layout, so that it just pads something, and you can define the padding, how much to pad. Okay, and the third thing is we can see the resource consumptions also. Okay, I'll just paste the code over here and I'll show you all the graphs. Now you can see this. This is the first graph where we have monthly revenue streams, product A, B, and C, and services, and then we have population growth by 8 different age groups, and now you can see this resource consumption over time. So now you can see this renewable resource, non-renewable, and nuclear energy. It is somewhat in the left upper corner. Let's move it to the upper, but this should be in the right. This should not be in the left. So let's move it in the right, so that it's also, so you can see this. I just moved it, and I told you that you can check the documentation to see where can we put these things, and you can also give coordinates if you don't find the space on the axis itself. I hope that this graph is also clear. So you might see these graphs sometime in the research papers, or maybe in some websites, and if you run a business, there will be a lot of these graphs where you have to make sense of these, and sometimes you might have this sort of data. So now you know which plot to use. Okay, and there are other different types of these things. We can do a lot of things with this. We can maybe set edge colors, and we can test with different things, but I hope that you will just navigate the documentation and see what things to do additionally on top of these. And now I just wanted to show you this graph. I hope this is clear. Now let's move to one more plot that's called as step plot. Okay, this is called as step plot. Any questions on the stack plot? Any questions? Okay, so now the second plot that we'll see for today is step plot. Okay, what is the step plot? So step plot, it creates a staircase like plot. Okay, this each that stair, it represents some data point. It has some horizontal and vertical line, so they'll be jumping the level. So where is it better? It is better if you have some discrete data, if you have some discrete values, not continuous values. So by discrete I mean, let's suppose if we consider stock market to be discrete, let's say if the stock price goes from 101 to 105 to 102 to 98, something like this, in each we are seeing that's after every 5 minutes. So this is at time 0, at time 5 minutes, after 10 minutes, after 15 minutes, something like that. So you can see that each of these things can be thought as a step. Okay, one step. So if you just plot this graph, it will be something like this. Let's suppose 101 is like this, and then we have 105 over here, then we have 102, that's over here, then we have 98, that's somewhere over here. But these steps will be connected like this. Okay, each of these will be connected like this, and they'll form some steps, something like this. So these things are called as step plots. So as I said that this will be quite useful if you are dealing with some discrete data. By discrete I mean which takes the jumps, and you can clearly see what jump it did take. Okay, and it can be, let's suppose, in the supply food chain, if you have this order fulfillment, or maybe you can also analyze web traffic analysis, because the numbers of the visitors are discrete, it's not continuous number. You have, let's suppose, in first 5 minutes you have some 100 visitors, in next 5 minutes you have some 120 visitors, and in next 5 minutes you had only 50 visitors, somewhat like this. Okay, so this value, if it is discrete value, so sometimes this step graph makes sense to use. Okay. So now what I'll do is again the same thing. I'll maybe create some data, bring the code window again. This is the data. So we have days, total 10 days, and then we have the stock prices for these number of days, and then we'll have this let's suppose visitors in the website. We'll again create some more data. But in the real world, the point is that you won't be creating this data. More of the times, 90% of the time, you will read this data from some file, and after that you will do whatever you want to do it. So here I created two types of data. I created stock data and traffic visitors data on your website, and then again the same thing. We'll create this figure axis and we'll create this figure axis of sub plus 2 plus 1, and then have a figure size, and then I have also added the subtitle. That basically means to add the title of add title to the whole of that figure. That's called as subtitle, subtitle. Okay, then the similar thing is the function that you will see over here is step function. Okay, you can check the documentation for it. So this is the function. I selected this axis and dot step, and then said days and the stock, and I said this is where is the post, and you can see this color blue, and you can here add some conditions also. Okay, I think we have seen this where when we were looking at fill between. Now if you see this is the step function. Okay, so this was the stock price, and then it is always going up, so I should bring it down someday. Okay, let us bring it down over here. Let's bring it down to 90. Okay, now you can see this, it should go down. So shouldn't it go down? It should always go up. No, I changed something else.
Change in the stock price.
Yes, I changed traffic visitors. I'll change it to 90. Okay, now you can see that it went down. So you can see it's like steps. Okay, and these sort of graphs are also useful when you are dealing with signals. Let's suppose you have these digital signals. There you might have seen such type of graph. Okay, how is the signal transmitting and stuff like that. And I would just add these title and legends if we have any. So I have X label, Y label, title. And you have you saw the subtitle basically is for the whole of this figure. This title is for just one of the axes, AX, ES axis, and then we can plot the same thing for the second axis. How to select that? Axis of 1, step, time periods, traffic visitors, and then I'm saying post and give color green. So here you can see these type of graphs. I want to adjust the layout also so that they don't overlap. Here they are not overlapping, but it is better to just make sure that you don't overlap them. Okay, and these are the step graphs. Okay, and these graphs can look sometimes if you have multiple series, you will see something like this. Okay, and you can make some unique graphs also. I was just testing some of the things. You can see this. If you have series 1, series 2, how do they interact with each other? And as I said that in these digital circuits, some people you might have seen that You can plot graphs like this, and with some markers also. Here I put some markers also, series 1, series 2, series 3, and these are the points. Okay, and you can make it in a way complicated, but I just wanted to show you that there are tools, and these might be used somewhere, and you should be able to read these graphs. Okay, and this looks quite cluttered. This, I didn't like it much, that's why I didn't explain the code, but it's quite easy. Just created 3 series, and after that you just plotted them on this graph. Okay, and these are the some of this pairwise data graphs, and there are a lot more. I think there are, if not hundreds, at least tens of these graphs. We have shown somewhat around 9-10, so there will be 10 more or 20 more of these graphs, but these are the most used graphs. And now we'll move to the different types of graphs, that's the distribution graphs. Okay, I hope that till here everything is clear. Any questions? I'll pause here for maybe a couple of minutes to take questions. Now we'll see what are the graphs that are related to distributions. Okay, so in the previous sessions we have discussed about what distributions are. I'll still slightly gloss through them to make you understand what distributions means. Okay, so if you see, there is uncertainty in the world. Everywhere we are surrounded by uncertainty. Let's suppose if you just take a person and somebody asks you, what is the height of the person? Okay, you cannot probably guess the exact height. But what if I gave you certain knowledge about the things? Okay, if we try to quantify certain things. So as I said, in distributions, let's suppose we'll talk about height of people. Okay, height of people. So height ranges, let's suppose, from 1 meter to 2 meters, something like this. If it ranges, if it's a continuous value, so height may take a value from 1 meter to 2 meter. Let's suppose I'm just let's make it more sensible. 0.3 meters. Let's suppose 0.3 meters to 2 meters. So this is the height of a person. That it can be any number in between this. Okay, if you just pick up a random person, okay, and see what is the height. Okay, that is what's called as sampling. You can sample. You just or walking through the street, and then you just saw a random person. You just asked him what's your height, and if he says that my height is 1.2 meters, something like this. Okay, what if we take all the people in the world and just list their heights? Okay, we take all the people, or maybe a huge bunch of the people, which actually at least will represent the population. So you know that what we can have, we will have a range of heights. We'll have 0.3, 0.31, 0.48, something like that, and so on, like this. And now what we can do is, if we somehow created bins, okay, by bins what I mean is, I'll say I'll create a bin from 0.3 to 0.4. So all the people that have height in this, so I'll keep them there. I'll keep a count of that. Let's suppose some 30,000 people have this height. 0.4 to 0.5, 0.5 to 0.6, something like this, and I'll keep the count. Okay, this will, if I just plot the graph, in this graph here I'll have frequency basically means our count, I should say count, and on this I have height, but this height now is divided into bins now. So if I can see, so from here this is 0.3 to 0.4, and then we have 0.5, we have 0.6, and the height will be somewhat like this, something like that. It will be like histograms. Again, the histogram that you saw, okay, something like this. Okay, but now what you can see is, there I have the concept of these bins. I have divided this whole data into bins. Okay, and then I have plotted something of a bar graph. This is called as a histogram. Okay, now the data can be of two types. The data can take continuous values. It can take continuous values like height. So height takes continuous values, or it can take discrete values. Let's suppose if you are rolling die. So if you are rolling 2 dice, you have one die and you have second die, you are rolling them, and you are seeing which number appears in the top, and you add these numbers together. Then whatever comes, you add that. And now what are the possibilities? The possibilities will be, numbers can be 2. Let's suppose 1 plus 1 is 2, 1 plus 1 is 1 plus 2 is 3, something like that, until 12. You can have numbers like this. Okay, you can have 2, 3, 4, something like this, so till 12. And now if you plot the histogram, you can say how many times, if I roll this die, let's suppose some 10,000 times. Okay, how many times will the sum 2 appear? How many times will this 1 plus 1 appear? How many times will sum 3 appear? Sum 4, 5, 6, 7, till how many times will 12 appear? So if you just plot the histogram, you will see something like this. I'm just making something randomly. So you will see things like these happen. So these things are discrete values. So now you can see, oops. If you see this, these are discrete values. So now you saw that data can be of two types. It can be continuous and it can be discrete. Continuous is as if you have height can take continuous values. In terms of discrete values, it will just jump from one value to another, from 1 to 3 to 4. It doesn't take the range of continuous values. And now they can be both infinity. Okay, they can be both infinite values. Okay, infinity and continuous is different. So continuous is if let's suppose I have to go from 1 to 2. If I take all the values in between, so this is continuity. Okay, and if I have, let's suppose if I directly go from 1 to 2, so that's why we use digital clock. Digital clock is somewhat discrete. It jumps from 1 to 2. If you have analog clock, while you have these second hand, you have the R hand, that moves slowly. It traces all the things. That's continuous. Okay, it is continuous. If you see digital clock is somewhat discrete because it takes a jump from 1 to 2, 2 to 3, 3 to 4. It does not go through the in-between values. Okay, so that's why computers are digital systems. Why? Because they jump, they don't have all the continuous range. And but 1 to infinity we can have numbers. Okay, the numbers can be infinite, but they may not be continuous. But in analog, these things can, if they are, let's suppose, continuous, and they might be infinite also. Okay, and they will be infinite. If you see in between 1 to 2, how many numbers are there? There are infinity numbers, something like that. Okay, because it traces all the numbers. So now the values can. Why am I talking about this? So in machine learning, your features will be either continuous or discrete. Let's suppose if you take height of a flower, or maybe length of a petal length of the flower, it will be a continuous value. If you take color will be a discrete value, because let's suppose there are 10 colors of a flower, so color will be a discrete value. That's why you will plot these histograms. Okay, so there will be a lot of data, and we'll have a distribution out of that. So there are a lot of distributions which probably will speak about these distribution in probability. There are normal distributions, polynomial distributions, Poisson distribution, exponential, uniform. A lot of distributions are there. Okay, but I gave you a generic idea how a distribution should be. So the first graph that we'll see, or a plot that we'll see, is called as a histogram. Okay, so in histogram we'll construct these rectangular bars. Okay, or what's called as bins, and each height of these will represent the frequency or a count of these points. Okay, and then we can create these bins, and we can have the distribution shape also. So so in the real world example will be height of people as I gave, or maybe exam scores. You want to see, okay, if your exam scores from 0 to 20, let's say, so you want to see how many people got 0 to 5, 5 to 10, 10 to 15, 15 to 20. You want to just see a distribution like this, and you will just get bars like this, something like this. Okay, and I'll just say 0 to 5, 5 to 10, 10 to 15, and 15 to 20. Let's plot this graph and so as to make it clear. Okay, let me just go to the code window and show you that. So again, we have to import Matplotlib and NumPy that I have already imported. So what I can do is I'll just first give this seed so that you can reproduce it if you can. Okay, I have just include this seed so that if you want to test this code, you can get the same results. So now I can create data set. So these are exam scores. So exam scores are from 0 to 1 and give me these 200 points. If I just print these exam scores, you can see these are the numbers. Okay, some got 44, some got 100. So I have these numbers from 0 to 101, and then these are 200 the score. Let's suppose I have 200 students. Okay, now if I want to print them, so what I can do is, the first thing I will do is I'll create some 3 plots, because I want to create 3 types of data sets. Now if you see this is figure, this is AXS, and I'm creating 3,1. So let's decrease this size. This will be 8, 10, something like this. Okay, I have created 3 plots. Now on the first plot, I'll plot these things by using the histogram. So how to do that? I'll show you that. So you'll say AX of 0, you'll select that, and you will have this function histogram. And then you have the exam scores. This is the exam score. And then I'm saying bins. That basically means divided into 10 bins. So 10 bins, basically, if you have 0 to 101, have 10 marks bin. So 0 to 10, 10 to 20, 20 to 30, something like that. And then give the color sky blue and give the color edge color black. So now if you will see this, so this is how the histogram is plotted. Okay, so as this you saw, there is some distribution followed. So I can just increase the number of bins. I can say, let's suppose 20 bins. You'll see now the bins will get increased, number of bins will be increased. Okay, so if I keep on increasing this, it will seem like continuous. If I increase, let's suppose I'll say some 100 bins. Okay, you can see now. Okay, now you can see these are thinning, and these lines are thinning and thinning. Okay, it looks like a continuous distribution after a while. If I increase it to the 1000 bins, so I'll keep it simple. I'll just keep it some 10 bins which I earlier had. This is what we will have. Okay, and in order to see this, you can directly go to the histogram function and see all the things that we can do with it. Okay, now I'll just set this plot and set the x ticks and maybe axis also. So how I can do it? X of 0, set title, set label, set y label, and give the grid of y axis, and alpha is this, and set x ticks like this. So I am setting it like this. Score range, and then this is the distribution of exams, and this is the frequency, or maybe I should have set count. I should have set marks or something. Frequency basically count, number of people. Number of people. Okay, so this is how you can plot it. Let's say second example can be, if you want to see, let's say customer ages. You have some customer and they have ages from 18 to 70, and you have such 150 customers, and you want to you have a website, or you have some you want to analyze how many customers are from a certain age group. So what you can do is you can just create a random data, and usually, as I said, this data will be given to you. So this is customer ages. So I am just randomly having age of 18 to 70, and I am having such 150 customers, and I want to just create a plot. So how to do this? Again, the same function, HIST. So this is, and this is customer. I have the sales data with me, so but I should have customer age. Okay, I'll do this like this. So axis 2, histogram, customer age, and bins 10. Color is this, edge color black, and distribution of this age range, and similar thing you can see over here. And similar for the sales. If you have sales data with you, let's suppose you are selling some things, and you have sales data, and now I can create a normal distribution. Okay, now let's create some more data over here. That's sales data with some mean and standard deviation. I'll tell you what normal distribution is in the probabilities class, but I hope that you can get this right away. And now if I just plot these things, so you can see this is my sales data. Now you can see this looks like a bell-shaped curve, a normal distribution curve. Okay, so now in nutshell, a distribution, it can be we can have a continuous value, okay, in which we'll just divide it in bins, or we can have discrete value. So you can just plot these histograms, and this is a simple example of histogram. I'll show you one more simple example of the histogram. Just give me a sec. I'll show you one more simple example so that you can directly see it. Not able to see the code window. Okay, so these are the simple histograms. So you can now modify these histograms also. So again, the same thing. So we have some random, let's suppose some 1000 points, and you just want to divide them into 20 bins, and then you will set these title, you will set the X label, Y label, and you can have a histogram like this. This is what we did in the previous examples. Now, what if you have two types of data and you want to see the distribution altogether? So what you can do is, if I have two types of data, let's suppose my data is like this. Okay, this is my data, and this is my data 1, data 2. So now I want to create two histograms. I can do it in the similar fashion. As I create the first histogram, I'll say AX histogram of data 1, bins 20, and this, and give the color. Okay, set the title, set the X label, and these are just color histograms. If I just want to plot, you might see the comparison like this sometimes also. So these are two histograms. Okay, the more bins you will add, the more smoother it will become. Okay, so if you just add these sort of things, so this is color 1, this is data 1 and data 2. They might follow two different distributions, and you can see them concurrently over here. Okay, this is one way of, this is another way of doing it. And you can have stacked, you can have stacked also. You can stack these things together also. How to stack them? Nothing, you have to do nothing. You just have to say this data 1 and data 2. So data 1 comma data 2 in the same one. It will stack them on each other. And now we have been seeing a lot of stacking. So you can see there is something. I have to put comma over here. Let me just write it so that I don't need to debug it. Here, if I have this data 1, this is data 2, and this is my AX. I have the data 1, data 2, and then here stack this 2. This is the one more thing that I have to take care of. So stack should be true, then it will stack this data, and label is this. I'm stacking this. You can see I have stacked the two distributions together. Okay, and this data 1 is this blue color, and the orange color is data 2. You can stack these histograms, and you can have the vertical histograms also. So in that, you just have to say orientation. You have to add one more thing, that's orientation over here. I said stacked over here, I should say orientation. So how to do that? Let me just create some more data to show you that. So if you see, same, I have created data histogram, but here if you see, I have added this orientation is horizontal. Initially orientation is by default vertical, so if you just flip it, it's horizontal. Now you will just switch the axis. Okay, this is how it will look. Sometimes this makes more sense, as you can see that sometimes these values can be quite long. So if you just want to shift the axis, you can just say orientation is horizontal. Okay, this is the histograms, and you will use them a lot. So once we'll go to probability stats, so all of our probability stats will mostly use this. So we'll just plot these graph, we'll have certain data, we'll just simulate a certain condition, and then we'll try to plot an histogram, and we'll try to get something out of it, and we'll try to fit a distribution. If we have a Gaussian distribution, we'll have some other types of distribution, and we'll try to fit or maybe we'll have data and we'll try to see which distribution it follows, or we'll have a certain process and we'll try to fit the distribution. Okay, so that you must know how to plot these graphs. So histogram is one of the functions. Okay, so this is in the distribution thing. Is it clear? Any questions on the distribution and the histogram plots? And you can check documentation for more details, and there you will get a lot of things which I am not covering here. I'm just giving you the sort of glance so that you know that these things do exist there. If you want to complicate it more, you can just go to the documentation, and there will be a lot more functionality that you can do over here. Okay, and then we have what's called as box plot. Okay, I'll also go there because most of these tools will use in EDA, in expert data analysis. Okay,